Well, welcome to you all for this second live event hosted in the context of the Swiss Digital Days. And I want to thank Nestle for offering the Alimentarium the opportunity to be here with you. Whether you are watching via Facebook, YouTube, LinkedIn, or Twitter, please do not hesitate to take the opportunity to ask questions. You'll be able to do so in the comment section of your platform. We will display some of these questions and our remark, and we will do our best to give you answers in the second half of this event. So my name is Nicolas Godino. I am one of the curator of the Alimentarium, a food museum located in Vevey on the Lemon Lake in Switzerland. You should come, it's wonderful. Today we'll be covering some aspect of a topic which is actually in the news right now, with the COP26 being held in Glasgow, dealing with and hopefully acting on global issues related to our very near future. Issues among which are food supply and the way we get this food. What is the impact of the way we produce our food? Which action should we make to get solution to some of the challenges ahead? Can technology be part of the solution? Basically, what would our food be in the future? Full of high tech or completely low tech? To go a bit around this topic, it is my pleasure to introduce our three guests tonight. We have Fabian Wall, which is a member of the executive board at Agroscope, head of the strategic research division, food microbial system, and Fabian is also president of the Swiss Food Research. Welcome, Fabian, and happy to have you here on.
Hello.
We also have Carol Plummer here, plant science and tech innovator. She's the co-founder of and CEO of Vivant, a startup devoted to working on biosignal, especially for developing plant monitoring technologies for crop health. Welcome, Carol, in that event.
Thank you very much, Nicholas.
Well, you're welcome. And finally, last but not least, we have a PhD student, Max Polzin, a PhD student at the EPFL in the CREATE Lab, which was recently founded by Josie Hughes, and the lab doing research in the use of autonomous mobile robots to enable novel agricultural applications. A lot of high tech there. I love that. Welcome, Max.
Hi, thank you.
So we'll have a few discussions with these three person here, guest speakers. Each of us will do a short presentation on our activities, what we are dealing with on our everyday life. And actually, I will start with giving you some context, maybe an overview of what we are talking about and what maybe the biggest challenges ahead. So I will share my screen, adding me to the stream. It's all white pages. Let's go back in time with this drawing from the Schweizer Chronique, made by Christoph Silbereisen in 1576, quite some time ago. It shows an agricultural field work in the 16th century on the Swiss plateau, with plowing, harvesting, haying, and vineyard work. All this could be considered quite sustainable, using only renewable energy. You can see man and animal power, wind, sun, water flows, and so on. Well, yes, sustainable, but maybe not providing that much of a food security and being quite sensitive to variation in climate. But that's been the way we've been preparing food for quite some time. That was in the 16th century, 17th century. If you go back to the 18th century, basically the technology has not evolved that much. It was the same type of tool, same type of technology, still very much renewable energy. So we have this picture from the 18th century by Charles Boyle, from the Encyclopédie ou Dictionnaire universel raisonné des connaissances humaines. So this encyclopedic time, and that was the 18th century. 18th century, you see on the left of my screen, there were basically 1 billion inhabitants on Earth. So that's column here. You see all these people there. That was the 18th century. Then after the 18th century, something happened, what we call the industrial revolution. And it's not just industrial revolution, it's really like a knowledge revolution. It's a medical revolution. Everything related to energy, knowledge, materials was then boosted. especially in material and life science. You see some of the topics like genetic selection by researchers such as Gregor Mendel, Charles Darwin. We have invention in medicine by Pasteur and Koch, Claude Bernard, Fleming. All these work into providing new medicines by harvesting knowledge, basically. Same thing on food preservation, fertilizer for food, and all that. Basically, also using a new source of energy, which did change a lot of things. Use of fossil fuel, coal and oil, providing a lot of workforce, I should say. So it was fossil fuel for energy and all their derivative, all the derivative of oil, the oil industry. Industrial Revolution starting 18th century, which provided a lot of benefits for humankind. Here you have some images of what it brought us, basically a decrease in infant mortality, like decrease in mortality overall, like an increase in life expectancy, decrease in diseases such as variole, I don't remember the name in English, decrease in poverty, increase in scholarization, illiteracy, a lot of different things like went way up in terms of human well-being, we should say. And for food, a large increase in food safety and in food security. It was less and less issues related to that. And that contributed to an increase in population, actually. Between the 1800 and 1960, you see that the population more than tripled. We went from 1 billion to 3 billion inhabitants on Earth. They were able to medicate themselves and to feed themselves, basically. And 3 billion inhabitants, starting in the 60s, we start to have good statistics about food production. So let's say these 3 billion inhabitants were using these 3 elements or these 3 units of food. I couldn't tell you if it's terabillion kilograms or whatever. That's a lot. And now if we look at where we are nowadays, in 2017, at least in 2017, we increase again the population, like by 2.4. So we have more than doubled the number of people living on Earth since the 60s. So imagine you take the whole population of the 1960s and you add them to themselves. That's the increase in population on Earth, and that was accompanied by more than an increase by 4 times of the food production. So there was a huge increase in the population and a huge increase in food production at that time, during this period. Summarizing this trend in population, so that's that curve that you see, like from the 17th century up to now. You see really an explosion in population growth, and really we are a lot on that planet, and much more than what we were in the 19th century or the 18th century. And what is expected to be is that in the coming years will still grow. So the rate will decrease a bit. So I think the peak population rate was attained in 1970, something like that. So it starts to decrease a bit, but still the slope increase. And by 2050, we expect to be growing by 40% more. So in 2050, there would be 40% more inhabitants on Earth. Inhabitants that will need to get medication, proper housing, clothes, and food. 40% increase, that corresponds to the increase we have just lived from the 1990s until 2015. There's been this increase of 40% inhabitant on Earth. So I don't know, but for me it's kind of astonishing. Like in my lifetime, well, it should be in the 60s, the population is still growing, and we are able to feed all these, almost feed a large proportion of these inhabitants on Earth. So if we look at what has been happening in the last 25 years, because to see what we could project for the next 25 years. So 1990s, we are this amount. We increased since 2017 by 1.4, a 40% increase, as I mentioned. And we see that the food supply was actually double, more than 100% increase, which means that we could foresee a similar increase in the near future, or need for an increase in the near future. An example of how we achieve this increase by 100% of food production, I'll give the example of corn production, which was achieved by actually increasing the cultivated area, which could relate to maybe deforestation or making room for new corn production. That accounts for 40% of the increase in corn production, but also by an increase by 50% in the yield. How much corn can you grow in a given surface of cornfield? So this combined increasing in cultivated area and in yield was able to double the production of corn in the last 25 years, which contributes to that doubling of food production, which hopefully are ultimately nourished this increase in 40% population. And that's what we'll be heading for the next 25 years. There will be an increase of 40% of the population. So we'll need to nourish the actual population, and we'll need to feed that added 40%. Will we need just an increase of 40% of food production? Would we need 100% as it was the last 100 years? I don't know, probably in between the two. We can did it. We did it for the last 100 years. Where's the issue? Well, actually, the issue is that we achieved that in the last century through, well, actually, we always did that, but intensively in the last century through deforestation. Deforestation was massive also in the 18th century, but that became really massive nowadays. So deforestation, we're losing some of the forest, and you all know the discussions around that, and losing some of the biodiversity and the lung of the planet, or the oxygen making of the planet. We also use that by irrigation, and it is estimated now that over 70% of the water currently consumed in the world is used for farming of the fresh water. Through fertilization, I told you about Haber, and that's the Haber-Bosch thing, that green revolution, knowing how to feed properly the plants to increase the yield, to increase the food production. We fertilized a lot this soil, and we also control by proper control of animal and plant varieties, that getting the right plant, but also controlling the invasive plants by using pesticides or insecticides, and making sure that the things we don't want are not in the field. All this actually was very efficient in increasing yields, but we now know that it's also very efficient in modifying our environment. And so that led us to this iconic picture of what actual agriculture might be, like a big field, monoculture, only wheat here being cultured, and that's the only thing we're doing. Classical picture of what intensive agriculture is. We did all that, and that contributed to something you might have heard of, which is the Anthropocene, which is actually showing that humankind has significantly changed its environment in a way that now you can see that from the geological footprint. So all these markers that we can monitor are impact of our activities. Part of it are agricultural activities, not only, but part of it on our ecosystem. It could be like raising temperature. You all know about that climate issues by raising temperature. It could be the release of like carbon dioxide, ozone pollutant, could be different type of pollutant that we find either in the soil or in the water, but also the loss in terms of number of species, biodiversity, the loss of available land to grow things. So that's the actual issue that is in part being discussed at the COP26 nowadays. Like, how could we stop changing all these parameters in the way that could not be sustainable either for human life? I guess the planet will still survive, but that's a profound change that Earth has never seen it at that rate. So yes, how do we reconcile these two issues? Like, we are a lot of people on Earth. We need to feed ourselves. We need to find clothes for us, housing, maybe other things. We know that it has an impact on our environment. What can we do about that? How can we feed everyone? How can we give clothes and shelter to everyone and stop having this strong impact on our environment? That's kind of a question. Should we continue as we did the last centuries? That's the left picture. We probably know that it's not the solution. Should we go back to what was the agriculture in the 18th century? Yeah, we can think about that, but would we be able to feed 8 times more people, like 10 billion people instead of 1 billion people? Is that sustainable? And do we all want to be like in the 18th century, like 90% of the population being working in the field, which means not contributing to anything else than food production? Or do our system need to accommodate for still having a significant proportion of our population doing something else than just spending their days in the field? These are accurate questions and a very, very valid question that we are having today. And I don't think there's a simple answer. I would just go rapidly through that. That's just an idea of what is a product life cycle. Like try to look at things one piece after another. That's what you do when you do product. But we could see that also for agriculture, for food production, like in that idea of producing raw material, looking at all these elements that goes into that product or that production. And that's what we have all been doing as society for years, for centuries, taking into account only a single element, which is basically the monetary value. How much can I afford? How much will it cost? Where could I have some cost savings? Where could I have value for my money? Like I want to be able to buy my food. So this monetary incentive was the key elements of our whole economy. We now know that we need to have the same reasoning, to have the same way of reasoning by taking into account other externalities such as the carbon dioxide emission, which used to have no cost. Now we know it has a cost on the environment. Could be the water use, could be a lot of other dimensions that needs to be taken into consideration and to be tackled and minimized and optimized as we used to optimize cost. Now that's a complex issue, and we won't cover that today. That's the idea was just like to give an insight of what's the biggest issue. I'm not inventing anything. I mean, all that is present in prospective works, some of which being presented by the Food and Agricultural Organization of the UN. In this document, for example, on the global trends and challenges that are shaping our future, which lists topics, issues that need to be tackled and way forward. So issues and actions that need to be made. I encourage you to read these documents. That's a very simple one-pager. Basically shows that there's a lot of action that can be made. And it's also shown that there's a lot of effort that needs to be made into research and development, that we don't have the solutions for most of these issues. We need to find new ways. We need to research new ways to do things. And we need to research, to understand, and then to develop solutions. That's where R&D is so key. This document is basically listing issues and way forward. There's many other documents. Some will be coming from the COP26 soon also. One here is from the World Resource Report, like what could be the things that we should make to create a sustainable food future. And they highlighted a few points. I just want to raise that idea of raising productivity. We need to be able to lose less. You know that we're losing basically, we're sparing like 30% of the food production goes in, it's not really into the bin, but we are losing 30% of our food production in the whole value chain. We need to raise productivity to lose less and to produce more, to be more efficient. And I highlight that point that we need to spur technological innovation. And that's we need to find ways which might be technological. Doesn't have all to be technological, but there might be technological innovation needed there. And when you think about technological innovation, we think of a country which is great in technological innovation, which is Switzerland. Welcome here. Wonderful country, still investing a lot into R&D and research. And I'm glad to have here three significant players in the field of R&D in Switzerland by having representatives from startups with Carol Plummer, from research organization with Fabian Wall, and from the young research like R&D people from the EPFL, the Create Lab, Max Polzin. So I'm really glad to have you here and hear what you maybe learning us or teaching us in this discussion. So I'm off. I hope you enjoy this introduction. I think in terms of walkthrough, what I suggest is maybe we have first a first discussion with Fabian Voll from the Agroscope to tell us about the research environment in Switzerland, maybe your own activity, Fabian, and then to move on with Carol about startup activities, what you are actually doing at Vivant, and then finish with Max, the future students. You are the future, and you will live in that future, and to have your crazy initiative coming up. Again, I encourage all of you following us online to ask us questions on your various platforms. We'll be answering them during the talk or afterwards. I'll remove my presentation. I don't know, maybe Fabian, Max, and Carol, do you first want to comment what I've been presenting right now?
I really enjoyed hearing what you had to say, Nicholas, and I thought you did a wonderful job of presenting the things that our achievements very positively. So the world population has grown enormously, and we are managing to feed people better than we have historically. So there are less people with lack of food today than there has been historically. So I thought you did a great job of painting a positive picture of our achievements.
Just would like to add one comment, Nicola.
Sure.
On the two pictures you showed from the 17th century on this monoculture, mainly in the US, the two pictures is also another significant difference, not only the world population, it was also the life expectation. So the first picture, when you would be our age, you would be real happy in this first picture. And we have almost doubled the life expectation this time from the individuum.
Yeah, part of it is food, part of it is medicine,
Yeah,
sanitation. Yeah. But we did. Yeah. So Fabian, maybe you want to follow up with your presentation. I can share your share is there. I had it to the stream. Here you are.
I need to. Is there an? You don't see my presentation mode? Is this correct?
We don't. We see your PowerPoint tab. We don't see your presentation full screen.
I need just to quick reshare. Sorry for this.
No problem.
What do you see now?
So we see the same thing.
Okay. So
maybe you can choose if you have two screens or you have only one screen.
No, I have only one screen. That what?
Okay. So and if you are in display mode, like.
Now. There was a small difference. Now you see it?
Yes, wonderful.
So there was an echo. No, that's better. So Agroscope is really acting in the applied research with as quick as possible know-how transfer to the practitioners, to food producers, and to the population as well in terms of nutrition. So this, and I really like our mission statement, good food, healthy environment, which shows that we want to produce food, but also want to protect our environment. So this is what I mentioned. We are in research and development for agriculture, for food, and for the environment. And this is just a picture when Agroscope in Liebefeld was founded in 1901. And perhaps someone remembers this building is still existent. It's today the Federal Office of Veterinary and Food Safety. And this was 1901. And having a recent picture, you still see here the old building, but you see already what the main change, and this is the loss of arable land. what we have. And so we need to produce on less area more food, as you have shown. And so that's where Acroscope is. And this shows that, and I think this is our activities are in these strategic research fields. And it shows that we almost cover the entire system from primary production, starting with all this grassland, the plant production system. We look for the protein supply. We have, but also the animal parts, so the animal food based on animals. We have all the climate, we have the biodiversity, we have these natural resources, but we have also then in number 10, the quality and product innovation for food, food safety, and nutrition. So we go from the field, how it is converted into food, which you can buy in the grocery store, and how you consume it with your own biological system. I will come back to this. In total, we are about 1,000 people, just to give you the size. And I want to show you one example here. And this is, we have this collection of microorganisms, which is used for a lot of, and this is where we bridge our legacy. So since Acroscope was founded, we collect those microorganisms. And I want to show, this was a science based on experience before, and with these new technologies of whole genome sequencing, we are now going into natural science in looking what are the differences of those organisms by whole genome sequencing. And we would like, because we know some of those microorganisms have a specific function, like they create a specific taste when you ferment food, or they have a certain risk to form antibiotic resistance, or they are food pathogens, which are toxic to us as humans. And we would like to find the genetic information on these microorganisms that we can have a much more focused design of experiment and can be more efficient also in the R&D process. By the way, some of these are also used to produce all our fine Swiss cheese. So we do regularly reproduce those materials for all the artisan Swiss cheese dairies. And this is, so these bacteria are named cultures, and I think it's a nice combination how we create out of microbial cultures part of our legacy culture, le culture suisse. When you look to this next genome sequencing, we have the standard sequencing procedures, the technologies, and then the data processing. And this is the key part, what we see in all our R&D processes, that our design of experiment gets more and more data driven. So we create this data, and then we try to structure this data and to create out of this data real new knowledge. And this is this process what we are using for these microorganisms, but also for molecular plant breeding or looking for phenotypic, genotypic in our animals, like the bees or the cows. And with this shows just the matrices where we look for food fermentation as a microbial system. This could be cheese, but could also be honey or bread or all this nice stuff, wine. We look also for the plants, because also in the soil are microorganisms which are key for the plants to get the nutrients out of the soil. It's not only the root needs, and there is an interaction with microorganisms. But then we look also into the human biosystem. And with the biomatrices, like urine or saliva or blood, we can see how our organism, with the microorganisms we have in our gut, digests the food and delivers us with energy for our own system, for our human biological system. And when we see, this is, I think all of us know this nutrition pyramid. I think it's in the third primary class where we learn this, how we should, how our diet should look like. And on the right side, it's not a pyramid anymore. It's almost more a Christmas tree. And there is something out of balance. And this shows that we cannot do R&D beside of the society. The R&D must be embedded into the society. We need to collaborate with the people that we can show it, and we can't bring this ready developed process. We need to engage the populations that we need to trigger change here as well. And when we see and how we want to develop this is this nutrient profiling out of our food, and then you see this metabolic process, how our organism gets the energy out of the samples in our gut system. And this could also be done with modern science technology, which is coming from pharmaceutical and clinical diagnostics research, metabolomics, all these omics research tools. And we bring this now into the Nutrigenomics part, where we want to analyze how the individual human metabolism uses the energy out of the food, and what are the and it's not only one component, it's our diet which drives this. And there we can then decide what is a healthy diet or less healthy diet. Because what we see today with this diet, as we have seen in the Christmas tree, that already today the dietary risks are by far the highest risk factors that we lose our daily living years. And this is the statistics for men, but it looks almost totally the same for the women. So our actual diet is not only not good for the planet, it's also not good for our health. And this we need to tackle. And because I mentioned it before, it's not good for your organism, but it's also not good for the sustainability. When you would adopt our actual diet behavior back to the pyramid, it would reduce the global footprint, the carbon footprint of our nutrition by more than 50%. And to do this, to make this change happen in the society, we need to talk with the people. We need to create citizen science approaches that the people are aware. What are the consequences of their behavior? It's not only throwing away food in terms of food waste, it's also this malnutrition, which is a main root cause for our high cost of the health system. So most of the non-communicable diseases are related with an unhealthy diet. We see this also in the most recently with the COVID situation. So the risk factors to get a severe illness out of an infection with SARS-CoV-2 from COVID with severe the risk factors are all coronavascular diseases, diabetes, heavy overweight. These are all the risk factors which are coming from malnutrition. And I think this was for me just to have a quick view into what we are doing at Acroscope. We are covering the entire system, but because I thought we have less farmers today on the call, I wanted to focus to this nutrition part and into this interface with our gut system, and that we need to talk with the society. We need to integrate the society into the R&D process. And I think this citation from Goethe is very nice. Food should please the eye first and then the stomach, because this will not happen with regulation. This needs to happen with a positive motivation, with the joy of food, with the joy of nutrition, with the joy of preparing a meal, because eating is one of our biological absolute elementary functions. So this was my quick presentation, and I'm much more keen to discuss.
Thank you, Fabian. That was clearly that was great, and I love that last sentence. I think that's very much what we're depicting in the museum too. Like there's a lot of interlinks, and especially I love the fact that you said that R&D should not be in silos, and things should be interrelated, like society, research, development, the science, the technology, food production. All these are linked together, and should be discussing one with another. And that's very.
And our main issue is that we sometimes exclude the human out of this ecosystem. but we are integral part of this ecosystem. And when we think we are standing above the system and can control it, it's wrong. We are a part of this system. And if you have seen, there are these comparisons. How human are we? When we look to our genes, what we have, the genes of the human body and the genes of the bacteria in our gut, we are more a microorganism than a human. Just by the number of genes.
We are the few genes directing the all other genes. Like there's the few genes up there that.
That's a question. Who directs whom?
Yeah. Well, there's a big field of science into like gut-brain axis. How our microbiota could be directing not our behaviors, but maybe our mood.
It will change. There is a direct connection with the vagus nerve from the gut microbiome to our central brain system.
There's wonderful stuff to discover, and as I mentioned, by getting to know better what is actually happening, that also drives ideas for solutions, doing things differently, like doing at the genomes, the genes of these organisms actually helps us maybe finding solutions to have new microorganisms, to make our food process different, to make the way we digest food different too.
But also, to be fair, without high technology like next generation sequencing or data processing with modern algorithms, we will not gain the knowledge to make the change.
Yes. Point taken. I think, and we noted here, I noted data-driven IT. We see how this new field, like starting from the 50s, like it's just a very new field of what is data, how we deal with that, big data and all that.
This is on bioinformatics, it's on the sequencing, it's with all this geopositioning system, with all this geodata. It's with if you look how the retailers, it's this transactional data in the supply chains, it's where you look, we are moving into this data-driven design of experiment.
Yep. Well, anyway, I think there will be a lot of discussion in the second part. We already have a few questions. I'd like to give the floor to Carol, if you wish, Carol, to present us a bit about what's your activity, what is Vivan doing, what is this startup doing? Actually, kind of wonderful stuff. Oh yeah, I've seen my eyes like this, but I'm too technophilic. I should refrain myself.
Thank you very much, Nicholas and Fabian. I really enjoyed your presentation. I work with people from Agroscope every day, and I learned a lot from your presentation. So it really pointed out to me the different facets of Agroscope. You really do have fingers in many pies. I also thought that the discussion on just where do new ideas come from and how are we going to continue to make the kind of scientific breakthroughs that are necessary to feed everyone, because I think for us it was really relevant to me. The ideas for our business came from a different sector. So I'm a mechanical engineer from Canada, and the core expertise of our business is understanding how information networks work. And we are applying that knowledge, understanding how telephone systems, radio systems work, to plants. So these things seem like they're not very connected, but I hope to show you in a few slides that they are really connected. So Nicholas, I'm very delighted to be here today. So we're the startup, and I'm going to talk to you about interpreting biosignals. And so I'm going to start by just telling you what biosignals are. And biosignals exist in all living entities, and the signals that we're particularly interested in occur when charged particles move across a cell membrane. So that happens in the bacteria in your gut, that is happening in your muscles, in your brain, and it's also happening in plants. So that's those are the signals that we're interested in today. And the signals we're interested in were actually discovered more than 150 years ago by an Indian scientist named Jagadeer Chandra Bose. And so they've been known about for a long time. But they're difficult to interpret because plants are doing many things at once. And so they're sending many signals across the plant. And the kind of core breakthroughs that we are making in our business are occurring because of data, because of information, and our ability to apply big computing power. So in our business, we are trying to work with growers and other plant scientists to improve crop yields and improve crop qualities while reducing the amount of inputs that are required to grow those crops. So reducing water, pesticide, fertilizer usage. So we are trying to improve the health of plants, and by doing that, the health of people and the environment around them. And some of the people, if you're growing plants, you may be aware, and if you're not growing plants tomorrow, when you look out your window, I really hope you look at them and understand they're not just sitting there. Plants are very, very active. So they are continually sensing what's going on in the environment around them and adapting, changing their responses to that environment so they can maximize their fitness. So they can sense the wind, temperature gradients, humidity gradients, touch, they have a sense of smell, and they're doing that all in the foliage, but they're also doing that in the root system. So they can move towards stronger nutrient gradients, towards water, away from stones. So plants are really highly active, and we tap into these signals that are being sent, the information being sent between the leaves and the roots of the plant. And we can interpret those signals using mainly using machine learning. This is just an example of one of our people in the greenhouse, and this is an example of some of the signals that we get. This is in fact a signal reminiscent of a fungal infection, so this is not a good signal. This plant is not very happy. And just to because this is digital days, I thought I would just focus on the digital part of our work. So we are capturing these small biosignals from the plant. So the movement of these charged particles across the cell membrane, they're measured in millivolts, and we measure now crops over the whole crop cycle. So the full life of the plant we can measure, and we can see in this graph, I've just got some, this was a really interesting graph for us. We can see when aphids are placed in a plant, we can see when the plant goes into this period of acute stress, and we can also see it when it's recovering from the stress after being treated with a crop protection agent. So plants are not just sitting there, they are very actively adapting to their environment. And with the help of technology, big data, informatics, we are able to start to decode the plant signals. And it's still early days for us. There's hundreds of things we haven't tried to do, but the success we're having is really, really promising. And again, as a small business, I wanted to just also take a couple of minutes to talk about kind of what drives us as a small business team. I think we are really driven to take the technology that we understand, apply it in a new area, and create benefits to make a contribution to a healthier environment, healthier people, and healthier communities. So we take kind of environmental impact measurement very seriously. So we started by establishing a really strong scientific foundation, and Agroscope was a key partner for us in this aspect of our work. With Agroscope, we've established the world's largest library of plant electrophysiology recordings. So this is like ECGs for plants, and we have 100 times more than the rest of the world put together. So Switzerland is really becoming the leading area for applied electrophysiology research. We've measured about half of the important crops in the world, so that means there's still lots left to do. And so far, we've been able to collect anecdotal information or anecdotal evidence of the improvement in sustainability that is created by applying our technology. The next step for us is really to try to do a much better job at quantifying those measurements. So that's something that we will be working hard on over the next couple of years. Obviously, you have to have maybe 3 crop cycles to get statistically relevant data. So that's something that we are working on. And I guess for Max, and if there's any other small business people out there, I just wanted to put a plug in for the B Corp certification. So we have our final review tomorrow. But the process of going through this application has been very beneficial for us as an organization. So I'd really recommend checking it out if you don't know about it. So that's really all I wanted to share with you today, but I wanted to just, hopefully inspire some of the people, let you know that here in Western Switzerland, we're really making some big strides in our understanding of plant electrophysiology and our understanding of how living organisms are interacting with the environment in order to maximize their fitness. And the better we get at harnessing those biosignals, the better I think we'll be able to improve the health of the people and the plants and the environment that supports us all. So that's all I wanted to share today, Nicholas. Thank you.
Well, thank you, Carol. I mean, that's amazing for me. I started my researcher career as in an electrophysiology lab, but putting electrodes on rodents' heads, and finding that into plants. That's kind of enlightening. Well, we know there's electrical signals and signals from plants. That's just wonderful. I was just wondering, like, would you be able to monitor or to see like what would be happening in the field, or there's a way, like, I know that what you're aiming at is just like getting knowledge, getting learnings to know when would be the best time to do things or to act. But could we foresee, like in the future, to have an online monitoring of a full field and to know exactly where to act and things like that? Could that be doable? Would that foreseen?
Yeah, it is definitely foreseen. So right now we are monitoring controlled environment agriculture, so indoor farms and glass houses, very well. So in fact, at Agroscope, we ran an autonomous irrigation trial recently. And so we used the plant signals. We're able to direct an irrigation pump to water the plants, and the plants did very well. But we are coming up with a new generation of the device that's much easier to deploy over large fields. And so again, we'll be trialing that in the coming season. So we'll be trialing that system in the spring.
Carol, I discussed this with Christoph. Do you see communication from plant to plant?
We see some evidence of communication from plant to plant. So I don't want to go too far and say there's, but yeah, we do see some evidence of that.
Yeah, super. It's unbelievable.
Yeah, it's amazing.
You need to grow some acacia then. Acacia well communicating one to another. Yes, that's really like one of the knowledge. Like we never thought about plant communicating among themselves, and it seems to be that there's some type of communication, and that's just wonderful.
It is, yeah.
Thank you, Carol. So we already have a few questions, but I'd like to give the floor to Max now, if you all agree, so that Max can give us some insight on what he's doing, on what the Create Lab at EPFL is actually working on. I think that's quite interesting. Max, the floor is yours.
Yeah, thanks a lot. Hi. Yeah, thanks for having me here. It's been great information. Some things that I didn't understand, other things that I understand, and that I hope to build up on. So, Carol, I wanted to ask you exactly the question that Nicola asked already. Where do you take these measurements? So I will be talking about that more a bit later. Fabian, you talked about data gathering, so I will also talk more about this, because this is what we're doing.
I saw your smile when I mentioned this.
Excuse me?
I saw your smile when I mentioned this.
Yeah, I was like, oh yeah, this is what we're doing. So that's a good fit. I'm in the right place. So yeah, the Create Lab is a new lab at EPFL. We are quite young. It was founded by Professor Josie Hugh. And what we are doing, or the name is the Computational Robotic Design and Fabrication Lab. So to summarize that, what we want to do in the Create Lab is we want to build better robots. Better robots is just a very vague thing. What is better? Are they faster? Are they cheaper? Are they maybe slower? Are they more sensitive? So it's difficult to like say something is better or worse. So what we think where we can build robots is in food and agriculture. So we want to like assess the performance, the quality of our robots that we build by providing good for food and agriculture. So like Nicola, you had a great introduction. Many of you probably know these 17 Sustainable Development Goals from the United Nations. Agri-food systems actually contribute to more than half of these Sustainable Development Goals. So if we achieve sustainable agri-food systems, we are on a good track to achieve the Sustainable Development Goals. And we in the Create Lab, we believe that robotics can be a part of this, a part of achieving sustainable agri-food systems. Now, we have seen this product life cycle or this food life cycle from you, Nicola, before. This is basically the same, just horizontally. We have the breeders on the left, we have the seed producers, then we grow the food, we process it, we have to distribute it, and in the end, we have the consumers that actually have to eat the food. So it's essential to us that's what we do this all for, right? And I will talk in the next couple of minutes about some of the projects that we have at the Create Lab, where like very just examples of what we are doing with our research activities to contribute to these bigger goals. So let's start here on the left on robotic navigation in harsh environments. So that's more on the grower side. Currently, we have robots that can work in warehouses, in indoor environments. These environments are very static, so nothing is changing. There's a lot of concrete. There don't grow many plants, maybe some microbes, but otherwise they are quite sterile environments, warehouses. We have been moved on. Well, we moved on to work. There are some companies like Carol that work in controlled outdoor environments. We have some mobile robots that can actually work in greenhouses. And part of our research is to actually like push these limits even further to work in fully natural environments. So to work outdoors where we have robots that can work, that they can navigate through muddy terrain, through steep terrain. So there's lots what still has to be discovered or developed in terms of technology to be able to truly operate in outdoor environments. Good. So once we are able to navigate in outdoor environments, then we can actually do new things. So this brings us to the data gathering, right? So we can do in-field monitoring. In the field, we can actually detect if my plant is healthy. We can maybe in the field at one day gather these electric signals from the plant and monitor, like maybe even analyze the genome. We don't know that when this is possible, but for that we need to be in the plant, in the field. We can estimate the yield. We can, if we detect diseases in the plants, we can intervene. Maybe we can reduce the amount of herbicides or pesticides that we use, and we just do some precision spraying. Maybe we can get rid of them entirely and just do some mechanical weeding and prune the plants, be cutting them. These are all potential applications that are enabled by this autonomous navigation. Now, if we think of a robot that we have in the field that can navigate through our field, we can also very easily imagine that we put a robotic arm or a mechanism on top of the robot, and then we can harvest some crops, right? So here that brings us to the next project. It's a work from my colleague Kai Junge, also in the Create Lab, right? So he built this raspberry. You can see this here. Everyone knows it. When you harvest a raspberry, they are quite delicate fruits. So when they are on the stem, you have to be very careful. And we humans are very good at grasping something and not destroying it. And then you have to pull it off the stem. If you push it, if you squeeze it a bit too hard, the raspberry is squished. It still tastes good, but you can't sell this anymore, right? So this is something. And if you want to automate this with robots have to pick them properly. They can't destroy them. So the problem is if you develop robots for agricultural application, and that is not only for the raspberry harvest, but for all harvest tasks in agriculture, that your field tests are limited by the crop growth. So raspberries, you can only pick when there are ripe raspberries. And if you want to work on picking them, actually, that you always have to, if there is a proper raspberry plant, you have to also maneuver from raspberry to raspberry. So this is like you have to solve two problems, like the maneuvering and going to the raspberry and the gripping and picking simultaneously. This makes it more difficult. That this is tough to do it. So what Kai has done is he built this soft sensorized raspberry, a physical twin. So it's a raspberry that has a sensor in it, an air pocket, and it can measure how much it is squeezed. So what I would like to, it has the same properties as a real raspberry. So this is very important. I would like to show you two videos. I hope you can see them well. So here you see the raspberry on the stem, and on the left you can see the sensor output when a human is squishing it. Now it's harvested, And when you see, you can still see how much it is squeezed. So from these measurements, we can compare them with real raspberries, and we see, okay, in my graph, okay, if I squeeze it this hard, then the raspberry breaks and it's no longer sellable, or is no longer a good raspberry. So this sensor we can then use to train our robots. So we don't build this sensor just for fun to be able to detect when raspberries are squished. We want to actually use this sensor to be able to build better robots, in the sense of that our robots can then harvest raspberries. So that's what you see here on the right. You see a very simple gripper, just these 2 3D printed plastic parts, and then the arm fails to pick the raspberry if it does not put enough pressure on it. If it puts too much pressure, it breaks the raspberry. And here in this part of the video, it just puts the right amount of pressure on it. And this sensorized raspberry helps us to develop better robots. This is, for example, one of these better robots, in the sense that it's better for agricultural applications. On the left, you see a hand that we developed, a very complex hand, actually. It has bones, tendons, silicon wrapped it. And this hand has the ability, the sensitivity to harvest a raspberry, but it's rather complex. Then one of our fellow students, Carlo, he made a very simple hand design. So this hand is fully 3D printed. That makes it very cheap to produce it. And it still has the flexibility or the properties that it can harvest a raspberry. So this is a better robot that is clearly better. It's an optimized design in the sense of costs. And it still is capable of executing a task that we want to. So this is how we design better robots. And the raspberry is in agriculture. Now, so these were these 2 projects. I would like to quickly show you 2 videos of some projects that are more on the other side. Fabian, you mentioned it, that it's also the customer that is involved, right? So it's like we are also on the other side. So robots can also be used to optimize, or not optimize, but help us producing food, actually, on the other side. So we have these 2 projects here. On the left side, you see a robot that is, wait, let me play the correct video here. So here you see a robotic arm that creates a hot beverage. So this robot takes a glass, takes some powder, and then creates a beverage. This is a very simple example of a robot that prepares a dish for us. The robot can then assess the quality of the dish that it made. So here the quality is assessed by the amount of bubbles, very simple assessment. And the robot can then optimize. It can vary its parameters. It can vary how it actually prepares the dish. And then it prepares a better dish or a better hot drink. So this is one idea or one project where you can see what a robot is capable of doing. And if you take this to the future, to the next level, you can think of robots preparing nicer dish, creating new dishes, even with better nutrition, and that are still tasty, so that we still like it. On the right side, that's the last video I want to show you. This is a robot that prepares an omelette. The robot cracks the eggs, mixes the eggs, puts them in the pan, adds some salt, and then cooks the omelette. And in this project, the robot would actually ask the human for feedback. How was this omelette? Did you like it? Did you enjoy it? Or should I prepare it differently? And this is a feedback loop, right? So if we have the human, we want to have the human in the loop, but maybe we can automate this process of the food preparation even more. Maybe we don't need to have canned food anymore and food with conservation materials in them. So we can just make the robot prepare it for us freshly. These are ideas. These are the research directions that we are exploring. Some of them. That was a very quick overview. Just want to conclude is that these are very specific examples. In all these examples, we should not forget about the big picture, right? So we need to feed more people with the food. We need to be more sustainable, use less water with it. And with our research, we aim to contribute to these bigger goals. And I hope that these very specific examples were a nice illustration of what we are doing. Good, thanks. I'm looking forward to all the questions, to the discussion. Yeah.
I want to visit your lab, Max.
Yeah. Very good. Yeah.
I love it. You making the sci-fi movie of the 50s real. So I love having being
I hope
served by
to.
all the 20 or 1920 robots serving my coffee and all that. That's really nice.
There's definitely inspiration in space robotics, right? So you have all these futuristic movies. You have The Martian, where they grow tomatoes or potatoes in a greenhouse and then with no gravity. And so this is inspiration for us, right? How can we make this more efficient so that we might be able to use it in our in the
Yeah,
future for us?
that's the thing. The way I view it, man. I know what some of the critics might be, that you are replacing humans. Are you more efficient than humans for picking raspberries? Are you more efficient
No,
than
at the
humans to
moment,
prepare a
not at
coffee?
all.
At the moment, no. But it's just fun to do it. But by doing it for fun, because that's really cool. I just love that. You will gain learnings. You will gain ways to analyze data. You will gain better learnings, and that might provide solutions for some of the issues that we may encounter. That you mentioned the freshness of food. Like, could we work without less preservative, or could we just fine tune the amount of fertilizer or pesticide that we need to put on crops? And for this, if you want to automatize that, to have that automatized, is that proper word?
Yeah.
Now you might want to use some robotics and some ITs and some big data to doing that. And so by having fun doing, well, at least I find it fun to have your robots serving coffee. I mean, there's a lot of learnings that could be brought there. That's
Yeah.
my personal view,
I know
but I
it
just
in Agroscope, right? So there is a project where robots actually measure the conductivity of plants, but in order like to monitor the stress level of plants. So this is a very interesting project. To do this, you get many insights from the electronic signals or electric signals in a plant, not electric. So, but you have to be at the plant, right? And currently, if you do this manually, is very, very time consuming, and you can't do it in an entire field. And then this is the idea that you can at one point use robots to do this on a larger scale to get more information, because in a field your crops vary throughout the field. You can collect data at certain points, but that doesn't, like, you can't conclude on the entire field.
No, I think that's exactly right. And I think that's where robotics could really play an important role. And this, so I'm delighted to see the work you're doing, and you talked about trying to build robots that could work on the slopes where we grow vines here. And
Yes.
I know that will be very challenging, but I think you will do it. And then we can bring that. This is some of the tools that are required really for precision agriculture. So I think it will take kind of some sensors and some looking at plants differently, like we do, plus some robotics like you do, plus some of the real plant expertise that resides in places like Agroscope, in order to really make an impact on the whole food chain.
Yeah, and it would be great to keep like what you mentioned, the vineyards, right, on steep slopes. If we have vineyards that grow wine, that grow grapes, that grow on slopes, it would be great to have robots so that we don't lose this farmland because it's no longer economically feasible because you have to do it manually.
Yeah.
It would be great if robots can help to weed in a vineyard so that you don't have to go there and take pesticides and just glyphosate and you spray everything and everything is dead. It would be great if you can just mechanically weed it and trim the grass or the weeds.
Yeah, exactly. I think also for our technology, we are doing autonomous growing, but we're really interested in deepening people's relationship with plants, because I think the more connected we are, plants are an integral part of our environment, and the more we are, the better we understand them, the closer we are to them. I think the more the better we'll be able to manage the ecosystem as a whole. So I think this deep relationship with other living things is a core target for us.
That's great. So we actually have a few questions that popped in during your respective presentation, and I suggest that we go through some of those for the latest one, first in, first out. We had from Mettons le Couvert for Max, are robots more sustainable than human for cooking? That relates to my question.
Well, that's a very, very difficult question. It's hard for
But
me
you
to.
need to feed your humans, and you need to pay the humans.
Yes.
And you need to provide him housing and clothes and food. So I don't know.
Yes. Robots don't need all this, right? is a question how you define your sustainability. Robots also need to be produced, right? You need to have materials. You can think of entirely new robots. Maybe eventually we will be able to produce robots made from wood or sustainable materials, right? So robots
or
don't
edible
have to.
material.
Yes.
You know,
Yes.
the edible robots project that's running also at the EPFL. That's a fun
Yeah,
one.
exactly. So there are ways, like, or there are ideas to go more in this direction, right? The robot does not necessarily need to be like, just because I showed a lot of arms, it doesn't need to be metal pieces and rare earth metals stuff. So there's also research going in direction to making robots or machines more sustainable. The question is how sustainable is a human for cooking? That is difficult for me to answer.
The question, I think, is how enjoys a human to cook.
That you don't want to take away, right? So there should always be this. Automation has the potential to automate tasks that you don't want to do, tasks that you actually desire to do. I think that should be great. I mean, I love going to the garden and planting. That's part why I'm here, right? That's part why I'm doing my PhD in agricultural topics. So going to the garden, growing my own tomatoes, and then doing some mixing everything together, growing that is very nice. But then again, we should not forget about the big picture. We have to scale this somehow. And then it becomes quickly very difficult to say, okay, we need to scale to 9 billion people in a bunch of years.
I have a question related to scale and to the idea was to use robot in real fields. Now, could you design the field so that it's actually adapted to the robots? I'm thinking of the indoor agriculture, vertical agriculture. You know, when you master all the parameters, and then you can design your agricultural principle to match the need of the robot's movement, and so they don't need to go into the mud. For that, you actually technology might be already here in the DARPA projects, whatever, you know, the robotic soldiers. I'm sure they go in the mud and they know how to move. Now to define robots for vertical farming.
This is an excellent point that you mentioned. Sorry, Fabian, did you want?
Yeah, I think there's also the point that we should take the chance and to look to the system and not try just to automate existing steps in our today thinking how we do it. Because when you think about vertical farming close to the consumer or this ultra regional production, can robots help to skip complete process steps which we have today, or in the sense of modifying a linear economy in the direction of a circular economy? Can robotics enable things which will not be possible without? I think we should focus things like this. Like when we look for this, when you under the where you have apple trees, you want to get out the grass below the trees that you see, and there are now robotics which just takes the grass, direct cut it small and take it, bring it back to the soil, and so you have a complete new process which is real enabled through using robotics. And I think it's real cool for testing the stuff to mimic how we do it today, like the cooking. I think it's nobody want to have in his kitchen a robot which makes my breakfast egg, but perhaps it could be nice as well.
You require a big kitchen.
We should think outside the box that robotics enable processes which are not possible or without.
Yeah. And you always have to see that then this is a research, right? So we are basically what we are building is ideas. We're trying to explore these ideas. That is there potential to do this, right? So this robot that you saw, you might have seen in the video that it was like ×5. So that means the video was in certain points, like in certain areas, it was just speed up by 5 times because the robots are complex. The algorithms that you need to do the calculations to actually execute this, detect it. Where's my egg? How do I have to grasp it? How do I crack it open? Very complex from a scientific point of view.
But I think at the end, this co-creation, that you as an expert, what can be done with robotic, and then you need other expert that you can define this new processes, or together with a consumer or with a chef in a restaurant. I have no clue. But I think
farmers.
Or farmers.
Yeah. I think all this, even if it's mimicking human activities, that's a challenge. I mean, that by itself, can we do it? But you will get learning by doing it. You'll learn new technologies, new way of doing things that you would not have thought about, and that can help also shape that new system. knowing this possibility. So we have also another question for Carol, actually, from Meton Couvert. Meton Couvert, it's a great podcast. If you can follow them on on Instagram, they're doing great stuff. For Carol, so did you measure the impact of plant growth in primary forest against large field crop?
We've only done a couple of measurements in plants really in a natural setting. So kind of we did bushes in the forest and ferns in the forest, and we see beautiful signals from them, but we haven't done enough scientific work to draw many conclusions from this. We've only done some work to see if it's possible. So it's definitely possible, and it's definitely underexplored.
Great. And we also had one question, which was early on by Theodora, which was asking Fabian, what research is currently done into understanding people's behavior when it comes to eating habits? I guess at Agroscope, there's a lot of studies being done, but
so in the moment that all the study needs to be in an observation mode, because we have all our brain, and as soon a human is knowing that you are part of an experiment, you behave different. So it's just this bias which we have, which could be to our fortune, but sometimes it's also not so good. Now, in the moment, we are building up competencies. One thing is we do social listening on social media, because food and nutrition is on all big social media platforms in the top 3 or 4 ranking of the content. And in the moment we do, but we are just building up this competence. So we are collaborating with computer linguists that we ask the right questions for the algorithms and how to, and we also clearly want to separate in the social media that we get real human input and not bot input. So we would real input. And we have now just made 2 experiments. What are the emotions from consumers when they are communicating in social media, different about beer, wine, or cider? This was just one of these easier questions, but to see, is there a different time point? Are there different emotions when you communicate about the stuff? Is it more with colleagues, or what is this exchange? This was our training part, and now we have another experiment ongoing where we are looking in this protein drinks, so this milk alternatives, what is communicated about oat milk, almond milk, soy milk, what is communicated about real milk, to see what are the consumers, because there is a real huge data amount which you can analyze. And the other part is that we are building up in the moment, or we are in the phase of building up a so-called food living lab, where we want to integrate society into those research questions, or take experiments to create the research questions. And the third part is we built in the moment, we had groundbreaking for our new canteen and meeting building. And in this building, we want to learn the competence in observation study, like during lunch, so that you can, when a person comes in, you with face recognition, you can identify, you see how long it's with eye tracking at the screen where you see the different options. Then you see where you get your food, what does you select, and then we can observe during taking your lunch. Do you eat all together? Do you things take aside, or how long do you eat? But I think it has to go over observation studies and the living lab. I think these are the 2 or 3 competences we are in the moment to build up.
And do people know that they are monitored in the canteen of Agroscope?
Yes, sure.
Yeah, so they are aware of it, so that over time they behave more normal.
We haven't. It was just groundbreaking for the building. We are just preparing the stuff, but there will be a plate that this area is monitored, and that you could be part of an experiment. So we have. It looks on all tables the same, but we will randomly just pick 3 tables.
That's very interesting. Yeah, that's very interesting. And I guess if it's a permanent installation, that then the behavior will normalize over time.
Yeah, since I think it's the first week, and then you're in the bias.
It will, and there's way to put that together. I know I've been working in that field for.
And
And
third part,
there's a lot of people doing this type of research, which are really, really great in terms of getting to better know our behaviors. And then you can do intervention. It's observational, yes, because you observe. You can also design interventions to see how interventions can change or nudge some behaviors.
yeah, we do already intervention studies. Otherwise, we couldn't do the. But these are people which is clear you are part of an experiment and you get a given diet. What we want to see is when you are free in normal life. And what we also want to use with a new partnership is engaging gastronomy as a multiplier. Special with all these new food materials, all these plant-based materials that are coming up to have like multiplier, because you need to train with this new set, you prepare it to its best, to the best taste, but also that you don't destroy proteins or other micronutrients during preparation.
Great. I think there's the last question for Martin Asher. That was probably when you were presenting, Fabian. That's what is the reason to have protein supplies as a separate strategic field and not carbs?
Yeah, protein supply is just a big area, because also when we see the global issues, there is a protein gap. There is a strong demand in different protein sources. If you look to the biological efficiency, and perhaps someone have seen has the Target show yesterday, so we are now just stepping into microalgae production as protein source. We need proteins for the animals, we need proteins for the humans, and that's the reason why we wanted to have this in a dedicated research field.
I have a question. Are there some studies in Agroscope to how you can change the behavior of people actively? Maybe
when you look to this Christmas tree, they have to change actively. Yeah. And I'm absolutely convinced that this is much easier by positive communication, by integrating the society, and not by more regulation. I'm absolutely convinced.
Yeah, I agree.
It usually doesn't work. Basically,
that's many bots, Twitter bots.
That's all.
Yeah.
It's all the strategy about the nudges. We've been talking about nudges, how we can trigger behavior by having something that could be fun to do, that people want to do, to go into a given behavior that works much better than forcing them to enter into some type of behaviors.
Comment, because the question was in regard to the carbohydrates. So we have programs there as well, special with new milling technologies that you can prepare without, that you can exclude in the milling process the gluten from the rest of the plant, that because we have an increasing number of gluten intolerance, but want also to deliver products which are in good natural processing, but there is also activities that we can exclude the gluten to the milling process.
Well, I think just one last question. I want to have this one because I think it will be part of the discussion in the future. Do you see food for future as microfood, like food focusing on our microbiome, that we would feed specifically our microbiome to then have, I guess, health benefits or to sustain ourselves?
That's already there. If you look breast milk, because when you are born for the first 10 seconds, you don't have a gut microbiome. This gut microbiome is starting to develop after birth. And in breast milk are real nutrients, which, and this is pretty recent research. In breast milk are nutrients which ending in an opportunistic selection of a good microbiome in the gut. And so the formation of a microbiome is always driven by competition for nutrition, and this is how it works. Yeah, absolutely. And this is also part more. So in the moment, probiotic, and this is still a good part, but I think there will be more diets focusing to host and keep a healthy gut microbiome.
So, and also tailored, I guess. So also specific to a certain person, because every microbiome is different, as far as I know.
Yeah, but it's not. At the end, you are right. But I think it has not to be real personalized. But you can have like big groups of special orientation, or it's that you can subgroup it and not complete individualize it. It's the same with a genetic part. The genetic part is just the foundation, and on top comes the epigenetic part, and this is so much difference, and yeah. But the best thing is that it will never get boring to do research.
Yeah, always new questions, and Max, you will discover that the more you advance in your research career, you see that the more questions will be opening, and then you'll feel, oh, I haven't answered none of them, only one, and there's so many to answer. That's the magic of it, and that's what makes us progress. Actually, that's all that process that's been going for centuries, but has been rationalized or put forward into what we could call the scientific process, how to move forward, how to learn from our mistakes, how to acknowledge that we're doing stuff in one direction and master those parameters. That's what I put in my style, into that industrial revolution, which has, for me, was much more than industrial. It's just to formalize this learning process and knowledge generation, and that's something we will definitely need in the future to tackle these huge challenges ahead of us. So, and I'm glad to see that a lot is happening in the area in Switzerland, and we have the opportunity to do that and to contribute through your various organizations, whether it's the Agroscope or it's fun and great new technological companies popping up with great ideas, not crazy, great ideas, or research lab with even craziest idea, and replacing my coffee makers by a robot arm. I love that. No, actually, the cherry picker, the raspberry picker, there's so much challenges there. That's really fun. We are way over the 1 hour time. I really want to thank you for your contribution, for your interest and engagement into this live event. So Fabian, Carol, and Max, thanks a lot. Thank you also to all of the online viewers. We are more than 25, I think, on average. That was good, and thank you all for your questions. Maybe if you want to say a last word, each of you. Fabian, do you want to conclude or say something?
No, just a fun comment to then to your mistakes. We need also biodiversity in mistakes. So we need a lot of different mistakes, but repeats the same.
Yeah. We need nice mistake biodiversity. That's cool.
And I'm just delighted to be here and be talking about the future of food, because if we get the future of food right, we'll have more people and more good people. And I think that'll make us an even better place to live.
Yeah, for me it was great to meet you, and I can only add that, Fabian, you mentioned that you would like to visit the lab. For also everybody that was visiting us, please feel free to reach out to us, and then I'm always open for new ideas, discussing questions and seeing what we can do.
Cool.
Great.
Super.
And you are all welcome at the museum, at the Alimentarium. Come and exchange. We will be discussing a lot about the future of food in the coming months. That's going to be the surprise of the new year. But we'll tackle this type of questions, and I would love to continue to collaborate with you, or to continue discussions with you and with you three, actually, on your respective topics, to then try to contribute, maybe make more events, or continue the discussion offline or online. This being said, it's getting late. Thank you all again for being here. Thank you all online also for following us. That was the great event. And this being said, let's look forward for the future of food. It's all ahead. Thank you all. So I'm ending the broadcast. Bye bye.
Good night. Bye bye.